left off yesterday. We're going to keep going, and then we've got some work to do on some similar problems during class. So, here we go. The first one, do you see how there was a question kind of up here floating? We still need to talk about that. It says, are the following linear or nonlinear? And so I never answered that about this question. So is this linear?
Yes.
Yes, it sure is. So this is linear. So I'm going to write myself a note here that it is also linear. All right, so let's come down here now, and I need to do part B and part C. So first of all, we need to decide if they're linear or nonlinear. And if they are linear, then we're going to go through and find the x and y intercept. If they aren't linear, then we're not going to do that. So let's look at part B. Is it linear?
Yes.
Yes. Why do you say yes? You're right. Do you know the reason why?
Way instead of y equals b.
Yeah, it is y equals mx plus b form. Also, our x is being raised to the first power. So look over at part C. With that same information, would this one be linear? No. So this one would be non-linear. It's because it's raised to the second power. Also, you're going to have a computer, and you're going to have the ability to use Desmos during the exam. So could you even type it in and look and see if it's a line? Yeah, you could do that too. So you could even write yourself a note that, like, plan B, right? So if plan A doesn't work, plan A would be just being able to look at the equation. Plan B, graph it on Desmos and decide if it's a line. And decide if it looks like a line. So that could be a note to write yourself. So again, plan A, we can always have good intentions and have a plan A, and that can be, like I said, just to look at the equation or look at the graph. But again, it's always good, especially on a test, when you get a little nervous. If plan A doesn't work, what's your plan B? All right, so for part C, the good news is we don't have to do x and y intercept because it's not linear. We do have to do it for part B, though. Okay. Do you remember how to find the x-intercept? If it's an equation. We plug something in. So for the x-intercept, that happens when y equals 0. And the y-intercept happens when x equals 0. So we're going to plug those things in to calculate it. So go back to your equation, and I'm going to plug 0 in for y. So 0 equals negative 1/2 x plus 7. Ooh, this is kind of ugly to solve. How can I get x alone? How could I get rid of this 7 friend over here? Minus, yep. So let's subtract the 7 over. So we get negative 7 equals negative 1/2 x. Now, I have two choices for what to do next to finish solving. Do you see how there's a 2 in the denominator? Yeah. So it's basically this is basically x being divided by 2. So I could rewrite this. Let me write this in a little bit different way. I could rewrite this as negative x over 2. Right? That x goes up into the numerator. So this goes here. All right, so if negative x is being divided by 2, how can I get rid of that division by 2?
Wait. Okay, I blinked real quick
and stuff happens. Yeah, okay.
Yeah.
So the x is sitting right here. It can stay there, but it can also go into the numerator. It can't go into the denominator because it's not being divided. It's not part of.
Is that a 1?
That's a 1.
Okay.
Yes,
Okay.
that's a 1. So it just went and joined the 1, and that's why there's nothing there with it anymore, because the 1, we don't usually write it. Huh?
Can I use a water, please?
Yeah.
Sorry, I'm about to like cough up my guts.
Oh, okay. Yes, go get a drink of
I'll be
water,
quick, I
please.
promise.
Good, I'm glad that made the video. Good stuff. Okay, next, we're almost done. So we've got x being divided by 2. How do I undo divide by 2?
U times by 2.
U times by 2. So I'm going to multiply by 2. Also, not just 2, I'm going to multiply by a negative 2. Do you see how if I multiply by a negative 2, the 2 is going to help me, and then the double negative is going to make it a positive x. So I'm going to do kind of double duty here, and I'm going to multiply by a negative 2. Negative 2 times negative 7 is what? Go get calculators.
14.
Go get them. It is 14. Go get calculators if you don't have one. So the 2's canceled, the negatives canceled, and I have x equals 14. Have I solved it for x?
Yes.
Yes. So that is my x-intercept. So my x-intercept is 14. So all of this work right here was for my x-intercept. So I'm going to circle it all so it's all kind of together. All right. Now I need to solve for my y-intercept. Do you see how my y-intercept is when x equals 0?
Yes.
This is going to be way easier. Watch how fast this is when I plug it in. So I have y equals, if I plug in 0, what's 0 times 1/2?
0.
0. So this just becomes 0. So y equals 0 plus 7. Well, what is 0 plus 7?
So
7. So this all goes with this. Yeah. Yeah, go ahead. Go grab one of the passes. Yeah. Go ahead.
For the x, you know you wrote y equals 7, can we write x equals 14 still be right?
Yeah. Yeah, the 14 doesn't need to come first. It can be x equals 14 or 14 equals x. That's not, and I think we've had that discussion before too. Like sometimes I'm picky about stuff. That's not going to be a spot where I'm picky about anything. Okay. All right, let's look at number 6. 6 is very different from the ones we were just doing. So 6 says, here's a graph. Is it even, odd, or neither? What do you think? I heard even. I agree with that.
Yeah, I said that in my mind.
You said it in your
I knew
mind?
you were a mind reader.
Oh, I was trying to. I didn't quite hear it, but I didn't have my ESP turned on. Okay, so even. How do I know that it's even? Because it has symmetry to the y-axis. You don't have to say why. Do you see how it doesn't ask me why? I'm just writing it down because remember, we can use this on the exam. So this way, if you look back later, you're like, well, why did I say it was even? So remember, this is our y-axis, and it cuts my graph in half.
So like, isn't that because like you could flip it and it would still be the same?
Yes, on either side.
Yeah.
And
like
so
here.
in particular, we can say too, it has line symmetry because that's actually going to answer the next question. So does the graph have symmetry? First of all, yes, right? Because it looks the same on both sides. We can cut it in half and it looks the same. And then what type of symmetry? I already said it. Line symmetry. So your choices for type, you only have 2 choices. Point or line. And if it's neither of those, then you can say neither. But point or line are your 2 types of symmetry that are possible. So if the answer is yes, it has symmetry, your choices are point or line. Yes?
Do we have to write lines in symmetry or can we just write line?
Do you have to write this?
No, do we have to write for if it has symmetry? Do we have to write
No.
line symmetry?
You would just write the word line. Yeah, you don't need to write all this. Again, I'm just kind of giving you bonus stuff. I'm giving you more than what you need so that hopefully it's reminding you how to do all the things when you get to the exam. So again, your choices are point or line. Of those 2 choices, this one's definitely line symmetry. So far, so good? Okay, let's flip to the next page. We're gonna do these three, and then we're gonna do some practice problems. 7 and 8 are almost identical to what we just did. So why don't you try those on your own? You can do that. No? Oh, resume. Okay. Here we go.
He did.
Let's take a look at 7 and 8. So number 7 was neither. So yes, it has symmetry, and yes, it has line symmetry. Because if I draw a line, right, it looks the same on either side. So yes, it has symmetry. Yes, it has line symmetry. The question would be, why isn't it even? Because the line symmetry isn't at the y-axis. So if you want to write yourself that note, you can. So it isn't even because the line symmetry isn't at the y-axis. So it has to specifically be line symmetry at the y-axis. So that can be, again, something kind of a bonus. No, there's nowhere in the question that says it's neither. Why is it neither? Right? So I'm adding that as kind of bonus material or information. And again, the reason I'm adding it is because when you go back to look later, you might be like, well, I thought it was even. Why isn't it even? Okay. And then number 8 I had you do. Now I'm giving you the answer. It's odd because it has 180-degree rotational symmetry around a point. So if I pick this point right here and I go zoop and rotate it, it would land back on top of itself. And not only does it have 180-degree rotational symmetry, but what do we call this spot where that point lives?
The origin.
Yes. So it has 180-degree rotational symmetry at the origin. Again, you don't have to write this. It doesn't ask, how do I know it's odd? But I want to make sure I tell you so that when you look back later, you're not like, oh, why did I write odd? What about that makes it odd? So this is what makes it odd. It's the 180-degree rotational symmetry specifically at the origin. So does it have symmetry? Yes. It's point symmetry because if I rotated, it would land right back on itself. All right, last one is end behavior, and that's what your extra practice work today is going to look like. It's going to be more practice on end behavior. Okay, well, it wouldn't be odd. It might have rotational symmetry, but it wouldn't be odd because it wouldn't be at the origin. Okay, here's what I care about. Do you see how this side's headed up?
Yes.
And this side's headed down? Those are the pieces I care about. I don't even care what's happening in the middle. Do you remember writing the statements as?
As x approaches,
Yes.
y whatever.
So positive infinity. Remember, positive infinity would be going to the right. Y does something. So I'm going to start my statement. I'm not going to write the answer, though. I'm going to do that in a minute. As x approaches negative infinity, and that would be to the left. Again, y is going to do something. So remember, this much of the statement looks the same every single time. The only thing you're filling in is this last little bit. Okay, so as we go to the right, so here I am, I'm going to the right. What's my graph doing?
Going down.
Going down. And we associate going down with negative infinity. Okay. Then this one says, as the graph goes to the left, what's happening?
Going up.
Going up, so positive infinity. Okay, so that's all we're doing there. So again, the only thing that I filled in, and you might even want to kind of like indicate this to yourself, these are the only pieces of information I filled in, right? The rest of it is what we write every single time. Yes? Yep, we're going to do the bottom one too. It says, state the point of any extrema and tell if it's a minimum or a maximum. Okay, do we have a point that's kind of a low point for the general area it lives in?
Wait, one more time.
we're looking for a point. It's not going to be the lowest point on the graph, but do you see a minimum point? Like a point that's low for where it is? Yes. So this one is going to be a minimum.
Oh, okay, yeah.
Do you see a maximum?
2?
Yeah. So I'm going to actually color code these because that's going to make it easier.
It'd be
So
like that
this
type
is
of-
my min, and we're going to say what the ordered pair is. So I'm over 0, but I'm down at what? -4. So any maximums or minimums we're going to state. So if you have like a peak or a valley, we're looking for the peaks or valleys. So this one would be a valley, right? Go down in the valley, it'd be the lowest point in that valley. Here we have a peak. So this is going to be a max. How far left or right do I go to get to that max?
2,
2 to the right, so 2 goes here. How far up or down?
0.
0. And so again, I think of them as peaks and valleys. So the peak is the max and the valley is the min. And you're just going to give the ordered pair that goes with it. And remember, this isn't like a Scantron sort of test. So I have markers, and you're welcome to use mine if using different colors helps you color code stuff, right? You can write in different colors. I know on Scantrons it's like it has to be a number 2 pencil and it has to be bubbled in super dark, and that's not what we're dealing with here. So, okay. How'd we do on that last one? Because that's what the homework's going to look like. Or not homework, classwork. Good? Okay.